Good afternoon, everybody. Welcome to the first lecture of EE 462. Today we'll go over some overview about the course. We already discussed the logistics in the class, no need to record them. So, in this course, we will talk about electric machines in details. We'll talk about steady state analysis, transient analysis, control, extra types of machines, etc. But before we proceed, for every electric machine, there is usually a block diagram that we follow for the electric drive system. So electric machine is part of the drive system. The whole thing is called drive. So when you hear the word drive, it means the machine, the power electronics, the load, the control, everything. But usually we refer to the feedback, closed loop feedback, and the power electronics involved in sensing the speed, the control unit of it, etc. So we usually have power source, power supply for the motor, three-phase or single-phase, depending on the load depending on the machine that you're operating. And then there is a power processing unit. This power processing unit, for example, is connected to the controller so that it supplies the machine with suitable voltage, suitable current, suitable frequency in order for the motor to operate and run the load. So this load, for example, this load can be a gearbox that is connected to a fan. Now, if the load is heavier, the speed of the motor will be smaller. صح ولا لا? So, but the torque will be higher. The torque will be higher, the speed will be smaller, so we need to control this machine in order to have this power. Power is usually, in electric machines, related with the amount of current injected in the machine. So high torque machine means high current is being injected from the power processing unit. So once this machine spins, we measure its speed, we measure its torque, and in a closed loop feedback, we send it to the control unit. The control unit would sense how much frequency, how much torque. It even processes how much current is being supplied and voltage, and adjust the command on the power processing unit to adjust the speed or increase the torque, etc. We also have a control reference. For example, we send a command signal. This command signal will tell, okay, you run this at linear function. Send a linear function. So the speed will start increasing linearly or exponential. Or I would say if you drive your electric vehicle, are you going to press linearly or are you going to press exponentially? So the control unit would tell you the pattern how you want to change the machine. Also, if you change the load, or for some reason you added an extra load, weight, the control unit would sense changes in the speed. And because the speed has changed, the requirements will also change. So we will try to explore how these modules work. And this is very specialized area. Not many people know about it. Most electrical engineers, they're focusing on optimization, protection, electronics, but very few people are experts in EVs or experts in even generators, how to excite them, etc. So we usually have power source, motor, power processing unit, or electronic converter. This is where we put a die, a rectifier, we put what do you call it? We put a transistor. IGBT, for example, is commonly used. We put in MOSFET. If you study 203, remember MOSFET. But those are power electronics, not small not 0.7 volt diode, larger diodes. And the control unit is a microcontroller, usually, like an Arduino, for example. Okay? And to build the hardware successfully, usually the drive engineers, they tend to simulate it using Simulink. And once they get the proper response, they go and design. Usually they buy the motor itself and they design the power electronics and the control algorithm for it. Okay? So it's a tremendous job. And there are, for example, Tesla, they have usually positions in, they usually buy motors, but they have what we call a traction application engineering. In an electric vehicle, they don't call it drive, they call it traction. Trains, for example, Metro Rail, it has these units. So the applications are very wide, but people underestimate how machines are available in the industry. And here we're not going to cover only the machine, we will cover the other aspects, how to control them, which is a job by itself. So again, this is a summary of all the types of machines. So we have AC machines. Transformers are machines, but they are machines without movement. They don't rotate. That's why their efficiency is high. We have induction machines, usually three-phase induction machine, but there is a special type, single-phase machine that has a circuit, that we need to have the circuit in order for us to operate this induction machine. We usually also have synchronous machines, permanent magnet, brushless DC, and synchronous reluctance machines. Different types of machines. For DC machines, we usually have DC motors, series shunt compound, you remember them from 360. I personally do not like DC machines, but they are there. They are there. Especially DC motors. Special types of machines, we have switched reluctance motor, universal motor, stepper motor. We'll cover universal, stepper, DC, induction, synchronous. Okay? Maybe quiz 1, I will ask you to fill in the blank. You don't like it, huh? Study.
أكيد.
You have to memorize. Who doesn't like to memorize?
I don't like to memorize.
You don't like to memorize. So
That's
we
why
try
we
to have.
came to engineering.
Yeah, but you still have to memorize.
أتسك والله.
We'll try to give you, allow you to write crib sheet or cheat sheet. Okay, maybe 1 page. I'm not gonna do it, you have to do it yourself. So in this course, the following machines will be covered. Synchronous machines. We'll cover generator and motor, salient, cylindrical, rotating, linear, dynamics, control of them. Induction will cover induction generator. Where induction generators are used?
شو بالجنريشن محطات التوليد.
Wind farms. Synchronous اللي محطات توليد. عشان يعطيك 60 هرتز. بس الاندكشن they're used في الwind turbine. Why? Because you can't control the wind. They rotate as long as the wind. We have 99 of them in Dawmat al-Jannah. We had a visit last December with Dr. Fahd Ismail and the master's student, and it was probably, I never expected it to be that huge. 99 is too much. And
ليش
each
ما-
one,
ليش مو 100 طفروا على آخر واحدة.
and two of them are down.
Right.
No, they have. You're right. Why 99? But they have north and south. Half of them will cover north substation, with south will cover south substation. So that if you get a failure in one substation, half of the wind turbines will be still operating. Also, I remember from their discussion that they said the induction generator is directly connected, ويعطيك variable frequency, is connected to power electronics module, that the output from the top of the wind farms is pure 33 kilovolt, 60 hertz sinusoidal signal. So they create they do 462 work on the top. before they extend the cable underground. So each tower will have cable, wind turbine have cables underground, it gives you AC signals. So induction generators are used in the wind farm, okay? DC motors, my least favorite type, they're available in trains, universal motors. Universal motor it can operate DC and AC together. And we have a stepper motor, which mainly the small motors that have steps, the robotat in the robotics. And the variable speed drives using pulse width modulated. So time is up. We finished the introductory part. Next lecture, inshallah, we will do a quick revision about the machines from 360. I added the link of my YouTube channel here. So once I upload the video, probably you will, it will be here in the videos, the latest videos, okay? And feel free to write comments, okay? So do you have any other question? Okay.